At 32 minutes past 8 on the morning of the 18th of May 1980, a magnitude 5.1 earthquake struck directly beneath the north slope of Mount St Helens. Somewhere between 7 and 20 seconds later, the entire north face of the mountain began to slide. It was the largest landslide in recorded history to happen on land, and it uncorked the volcano. 6 miles to the north, a 30-year-old volcanologist named David Johnston was sitting at an observation post called Coldwater 2, where he had spent the night. At 6 that morning, his measurements showed nothing unusual. 2.5 hours later, he had just enough time to reach his radio. His transmission was, "Vancouver, Vancouver. This is it." Those are the last words anyone heard from him. A search found nothing. In 1993, state highway workers found the remains of his USGS trailer. Further north, an amateur radio operator called Jerry Martin was watching from higher ground, and he saw the blast overrun Johnston's position. His transmission is one of the most extraordinary documents of any natural disaster. He said calmly, "Gentlemen, the camper and car that's sitting over to the south of me is covered. It's going to hit me too." And then his radio went silent. 57 people were killed that morning. 230 square miles of forest were flattened. The eruption column reached the stratosphere, and ash fell in 11 states. And the essential shape of it, the bulge failing, the north side collapsing, a violent eruption following, had been set out in writing 17 days earlier by a man who was not even on the monitoring team. Mount St Helens had been quiet since the 1850s, 123 years of dormancy. It was a postcard, symmetrical, snow-capped, with a lake at its foot. On the 15th of March 1980, small earthquakes began. On the 20th, a magnitude 4.2 shock beneath the north flank announced that magma was moving. Within a week, the earthquake swarm was saturating the local instruments. On the 25th of March, it began to climax, and in the days after came a magnitude 5.1 among 174 shocks of magnitude 2.6 or greater. On the 27th of March, steam explosions blasted a new crater 250 feet wide in the summit and threw an ash column 7,000 feet into the air. A 4-mile-long fracture system opened across the summit area. 2 days later, a second crater appeared, and a blue flame, probably burning gas, was seen playing between them. Static electricity in the rolling ash clouds threw out lightning bolts up to 2 miles long. On the 30th of March alone, 93 separate outbursts were counted. On the 1st of April, harmonic tremor was detected for the first time, the continuous rhythmic shaking that means fluid magma is moving. That alarmed the geologists, and on the 3rd, the governor declared a state of emergency. On the 30th of April, an executive order created a red zone around the volcano. Being caught inside it without a pass carried a $500 fine or 6 months in jail. And then there was the Bulge, which is the reason this episode exists. In the last week of April, a USGS team determined that a section of the north face 1.5 miles across had been pushed outward by at least 270 feet. Through the rest of April and into May, it grew by 5 to 6 feet a day. By mid-May, it stood more than 400 feet out from where the mountainside used to be. 5 feet a day. You could watch a mountain deform on a weekly basis, with surveying instruments, from a ridge. Behind the bulge, the summit sank into a complex, dropped block. The volcano's total volume grew by about 1/10 of a cubic kilometer. That volume was magma, pushing into the mountain and deforming it from inside. Because it never reached the surface, it has a specific name, a cryptodome. A hidden dome. About 10,000 earthquakes were recorded before the 18th of May, most of them concentrated in a small zone less than 1.5 miles directly beneath the bulge. Now, the part of this story that deserves to be better known. A USGS geologist contacted a landslide specialist called Barry Voight, not a volcano expert, a landslide expert, and asked him to look at the bulge. Voight observed the mountain between the 11th and 19th of April. His assessment was that the bulge could fail and take the volcano's entire north sector with it. He advised them to monitor the rate at which the bulge was moving. He also suggested hiring a local surveyor to take the measurements, which offended several of the geologists. On the 1st of May, he sent the USGS his full report. It predicted the failure of the bulge, the collapse of the mountain's north side, and a violent eruption following it, and it called for an extensive evacuation zone. 17 days later, the bulge failed. The north side collapsed, and a violent eruption followed it. It is important to be fair about what that does and does not mean. Voight identified the mechanism and the danger. He did not, because nobody could, say which morning. And the scientists on site were not ignoring the risk. Their work is precisely why the mountain was closed to the public, and why that closure was maintained under heavy pressure to reopen. That closure is the reason this was a disaster with 57 deaths rather than one with thousands. Because on the 16th of May, the visible eruption stopped. 2 months of steam and ash, and then nothing, and the public lost interest, and the crowds thinned. Pressure mounted. On Saturday the 17th, officials allowed 50 carloads of property owners into the danger zone to collect what they could carry. A second trip was scheduled for 10 o'clock the following morning. That was Sunday the 18th. The eruption came at 8:32. The convoy would have been inside the zone by 10. And because it was a Sunday, more than 300 loggers who would normally have been working in that forest were not there. Before the mountain goes, it is worth knowing who was standing 6 miles from it. David Alexander Johnston was born in December 1949 at the University of Chicago Hospital and grew up in Oak Lawn, Illinois. His father was an engineer. His mother edited a newspaper. He took photographs for his mother's paper and wrote for his school newspaper, and he went to the University of Illinois intending to study journalism. Then he took an introductory geology class and changed his major. His first geological project was Precambrian rock in Michigan's Upper Peninsula, the remains of an ancient volcano, reduced to metamorphosed basalts and the roots of intrusions. Studying a volcano that had been dead for a billion years planted the seed. He graduated in 1971 with highest honors and distinction, then the San Juan Volcanic Field in Colorado, working on 2 extinct calderas with the volcanologist Pete Lippman. Then graduate work in Seattle, reconstructing the eruptive history of volcanoes that had stopped erupting 30 million years ago. Reconstructing dead volcanoes is how you learn to read live ones. In 1975, he did a geophysical survey of Mount Augustine in Alaska. When Augustine erupted the following year, he raced back to Alaska, shelved his Colorado work into a master's thesis, and made the eruption his doctorate. Augustine also nearly killed him. He was trapped on the island while the volcano was building toward another eruption. His thesis showed 3 things: that the way the pyroclastic flows were emplaced had changed over time, that the magmas were loaded with water, chlorine, and sulfur, and that mixing thick silicic magma with runnier basaltic magma underground could set off an eruption. In the summers of 78 and 79, he studied the ash flow sheet left by the 1912 eruption of Mount Katmai in the Valley of 10,000 Smokes. His specialty was gas. He mastered the techniques for analyzing tiny vapor inclusions trapped in crystals inside lava, which record the gases present during eruptions long past. Colleagues described his agility, nerve, patience, and determination working around jet-like fumaroles in the crater of Mount Magic. He joined the United States Geological Survey in 1978, monitoring volcanic emissions across the Cascades and the Aleutian Arc, and helped strengthen the idea that eruptions can be predicted, to a degree, by watching how a volcano's gases change. A colleague later said that Johnston's dearest hope was that systematic monitoring of fumarole emissions might allow eruptions to be detected in advance. He believed scientists had to do what was necessary, including take risks, to protect the public from natural disasters. That was not a slogan. It was the argument he and his colleagues used to keep the mountain closed. He never married. He was 30 years old. The landslide traveled at between 110 and 155 miles an hour. Part of it struck a ridge 1,000 feet high 6 miles away. Some went over the top. Most of it ran 13 miles down the North Fork of the Toutle River, filling the valley up to 600 feet deep. Removing the north face released the pressure on the magma inside, and the mountain exploded sideways. At the vent, that lateral blast probably lasted no more than about 30 seconds. The expanding cloud kept moving north for about another minute. In that minute and a half, it destroyed an area measuring roughly 23 miles by 19. The innermost zone, about 8 miles in radius, is called the tree removal zone, because virtually everything in it, natural or artificial, was obliterated or carried away. Beyond it, out to 19 miles, is the tree down zone, where the blast flattened everything in its path and was channeled by the terrain. In that zone, the trees lie parallel, snapped at the base, all pointing the same way, as if a scythe had gone through grass. The energy of that blast has been estimated at 24 megatons of high explosive. The total thermal energy of the eruption at 26. The blast cloud was still 680 degrees Fahrenheit when it reached its first human victims. Most of those who died were asphyxiated, several died of burns. Harry Truman, an 83-year-old innkeeper who ran the lodge at Spirit Lake and had refused every order to leave, was buried under about 150 feet of avalanche material. He had become a folk hero in the weeks before, an old man with 16 cats who told reporters the mountain would not dare touch him. He was a World War I veteran whose troopship had been torpedoed off Ireland. 2 photographers died. Reed Blackburn, working for a local paper in National Geographic, was 8 miles out at Coldwater Creek. Robert Lansford was within a few miles of the summit when the ash cloud reached him. He kept photographing it as it came, then rewound the film, put the camera in his backpack, and lay down on top of it. His body shielded the film. The photographs survived and gave geologists a direct record of the advancing cloud. Another sequence survived by accident. Gary Rosenquist was camping 11 miles away and photographed the collapse frame by frame. The blast was deflected by the terrain a mile short of him. From his photographs, scientists reconstructed the motion of the landslide itself, the sequence that turned a catastrophe into a case study. The eruption column rose 80,000 feet, about 15 miles, deep into the stratosphere, and it kept going for 9 hours. Ash fell across 11 states and into Canada. In Yakima, 100 miles east, the streetlights came on at midday, and the city shoveled ash off its roads for weeks. On the mountain, snow, ice, and several entire glaciers melted at once, and the meltwater mixed with ash and debris into lahars, volcanic mud flows with the consistency of wet concrete. Those lahars ran nearly 50 miles, all the way to the Columbia River, taking out bridges, houses, and highway as they went. Spirit Lake took the strangest blow of all. The landslide displaced its water into a wave about 600 feet high, which ran up the ridge to the north and came back carrying thousands of uprooted trees. When it settled, the surface of the lake stood about 200 feet higher than it had that morning. 4 decades later, those log mats are still there, drifting around the lake with the wind. And the trees that were not completely torn from their roots did something remarkable. They turned upright under their own weight, waterlogged, and sank into the mud at the bottom. In the oxygen-poor, mineral-rich water, they are slowly petrifying, which has given geologists a live demonstration of how upright fossil forests form in the rock record. A catastrophe that killed 57 people is also, now, a laboratory for reading much older catastrophes in stone. Mount St Helens has been erupting on and off ever since. A lava dome grew in the new crater, then another, and the mountain has spent decades quietly rebuilding itself. By the 2000s, it was steaming again, with a new dome growing inside the crater the blast had left. The area became the Mount St Helens National Volcanic Monument, and Washington State made May Volcano Awareness Month. There are 2 volcano observatories named after David Johnston. One is in Vancouver, Washington. The other stands on the ridge where he died. And this is where the story turns from a disaster into something more useful, because the science here worked. The volcano was monitored, the mechanism was identified, the specific failure mode was described in a report 17 days ahead. The area was closed, and the closure was held against real public pressure. What could not be done, then or now, was to name the morning. Volcanoes do not work on notice. So, the deaths cluster in a very particular way. Almost everyone who died was outside the restricted zone, or had a reason to be inside it. Johnston was there to watch it. Blackburn and Landsberg were there to photograph it. Truman refused to leave. Jerry Martin was on a ridge with a radio, reporting. Johnston had argued that scientists must do what is necessary, including taking risks, to protect the public from natural disasters. He is one of only 2 American volcanologists known to have been killed by an eruption. The other was his own student. 46 years later, the crater is still there, the dome is still growing, and the ridge where he sat carries his name and an observatory full of people doing exactly what he was doing. The mountain gave 2 months of warning. Someone wrote down precisely what would happen, and it still cost 57 lives, because the one thing nobody could supply was the date.